Hi students, let us continue with the DFS. Let's take one example. So here I am taking one example. So this is the same example for whatever I had taken for the BFS. Now let us see what is this. So first what I have to do, I have to start search at vertex 1. So now I am starting the search at vertex 1. So I have to, whenever I visit that, I have to label it. Label vertex 1, okay, and do depth first search from either 2 or 4. So I had to search for, I had to do the depth first search on 2 or 4. Okay, so suppose I had taken that, suppose I have taken the vertex 2. Okay, vertex 2 is selected. So let us take the vertex 2 is selected. Okay, now coming to the second point. Second, again label. Now I selected 2. Now you have to label 2. Label vertex 2 and do depth first search from either 3 or 5 or 6. So the adjacent elements, vertices for 2 or 3, 5 and 6. So you have to do any of the vertices. So you have to select any of the vertex. Suppose I have selected 5. Okay, suppose I have selected 5. Now I have to label it. Label vertex 5 and do depth first search from either. So what are the adjacent for 3, 5? 3, 9 and 7. So 3, 7, 9. 3, 7, 9 are the adjacent for this vertex. Suppose I am taking 9. I am selecting 9. Now fourth. Now I have to label vertex 9. Label vertex 9 and do depth first search from either 6 or 8. So what is the unvisited vertex? 6 or 8. 5 is already visited. So just select the 6 or 8. So in this 6 or 8, I am selecting 8. Suppose I am selecting 8. Suppose 8 was selected. Now fourth step. Now I have to label 8. I was selected. Now label 8, vertex 8 and return to vertex 9. I didn't visit all the vertices, so I had to again backtracking. I have to return to 9. Okay, so now from vertex 9 do depth first search on 6 because 6 is not visited. So I'm backtracking it, and again from 9 I have to search which one is not visited. So I have to do depth first search on 6. Okay, so do depth first search on 6. Now coming 6. Now label vertex 6. Now it is, the 6 is has to be the, you have to label from here, you have to start and do depth first search on from 6. What are the adjacent values? From either, because 4 is not visited, from either 4 or 7. So from 6 to 4 or 7 are not visited. So you have to do depth first search on 4 or 7. So let us take, suppose I am taking the value 4 I selected. Okay, so now I selected 4. Now I have to label it. Now label vertex 4. Okay, now I came to the 4. Now I have to return back to the 6 because 1 is already visited but 7 still not visited. So I'm just return to 6. Okay, so from 6 do DFS on 7, means depth first search on 7. Now I visited 7. Now I have to label it. So label vertex 7 and return to 6. Again I am returning to 6. So whenever I label to 7, again I back returning to the 6. Okay, so whenever I return to the 6, I'm checking whether because 3 is not visited up to now, so I just return to the 6. So after returning to the 6, again let me write that, return to 6. Ninth one is next, return to 9. Return to 9. So again return to 5. So from 9 to, again I'll return to 5. Next, do DFS on 3. So from 5 I have to do DFS on 3, depth first search. Okay, so now I am checking whether all visited or not. 12. Label, now label 3 and return to 5 and return to 2 and finally return to 1. So what I am saying, while I am returning to 2, I am returning to 1, everything, because here I am emptying the stack. So whatever the values that are entered, okay, I am just removing the values from the stack by just returning back. I am just removing the values from the stack. So this is an example for DFS. So let me take the stack, then you will clearly understand. I am taking another example for the DFS, then you will clearly understand what I have said up to now. Why I am just returning back from one vertex to another vertex. So let me take another example. Suppose this is A, B, E, C, G, H and D, F, from F to T. Okay, let's take this is a graph. Okay, here I am taking this stack. So I am writing the output here. So first what I have to start the value from A here. First I have to put the value of A in the stack, write the output. So what are the adjacent vertices for A, B and E? Just I am taking alphabetical order. So now I am selecting B. So that has to be entered into the stack and write it in the output. So there are no more values that are adjacent to the B. So just pop it. Stack, the topmost element you have to be deleted. Okay. So now A. So what is the adjacent value for the A remaining still? E. So just enter into the stack and write here. Okay. So now there are no more adjacent vertices for A. Just pop it. Okay. Now coming to the E. So what are the adjacent vertices for E, C and H? So just I am taking the alphabetical order. So C I am entering into the stack and writing here. And now from C, what are the adjacent vertices? D, F, G. So I am taking D because that is next after C, D. Just enter into the stack. Okay. So from D, there are no adjacent vertices are still remaining. Just pop it. Okay. Just pop it. So from C, another next vertices or the adjacent vertices is F. So just enter the value F. From F, what is adjacent vertex? I. Enter the value I into the stack. Okay. So from I, what is adjacent vertex? H, that is not visited. So enter H. From H, E is already visited. So enter G onto the stack. Okay. But here all vertices are visited. But the problem is not over. because the stack has to make empty. You have to make the stack empty, but here the stack is full. So you have to pop all the elements, the top elements one by one by checking whether the adjacent vertices are visited or not. Now just do the pop. So first G. So for G, already C is no more adjacent vertices or unvisited. C is already visited, H is already visited. Just pop it. And coming to the H, E, G, I are all visited. Pop it. Now coming to the I, F, H are already visited. Pop. Coming to the F, C and I is already visited. Pop it. Now coming to the C, E, G, F, D already visited. Just pop it. Coming to the E, so A is visited or H is visited and C is visited. Pop it. So now stack is empty. Stop this search. So this is how I'm just backtracking example for the depth first search. Thank you.